Hi, I am Paniher.
Hi, I'm Erin.
Hi, I'm Varshini.
Hi, I'm Ganjungji.
We are FSPM.
So hello everyone, I'm Erin and today I would be giving you a general idea of what is conic section. So conic section is basically a curve that intersects to a cone. From the name you can tell conic section, so it's something to do with a cone, and I'm going to show you how conic sections is related to a cone. So now as you can see, we have this plane here which is intersecting through this cone. So once it intersects through this cone, you will get this shape, a circle, which is one of the conic sections. And now you get the second conic section if you tilt it a little bit. Let me just move this a little bit down so you can see it clearer. You would get, I think you guessed it would be an ellipse, which is a tilted circle. So now, as you can guess, we would get another conic section if we tilt it a little bit more. And now we would get a parabola, which would be our main topic of today. Which would be the main character of today. So now moving on, last one is a hyperbola. So I connected these two cones together, and if you intersect it, you would get a hyperbola, which is basically two parabolas. So that's it from me.
Right now, I'm going to be explaining what is a parabola. A parabola is a curve in which each point on the curve is equal distance from a fixed point called focus and a straight line called directrix. Next, I'll be explaining the uses of parabolas. One of the main uses of parabolas is in bridges where it is used to withstand more weights. This is due to the shape of the parabola being able to distribute force evenly throughout the whole bridge. This prevents bridges from falling down due to overweight. Next, parabolas are also used in satellite dishes as they are able to reflect signals onto a single point, which is not possible with other shapes such as spherical or flat. Satellite dishes are mainly developed by NASA scientists.
So as you can see, this is the picture of example of the tower, and I've written down that it's 1280 meters away, apart from two towers, and this will be 160 meters. So the midpoint of this will be half of 1280, which is so that's the midpoint of the two towers. So as you guys know, the equation for vertical parabola will be x minus h square equals to 4p y minus k. So in this case, we are going to substitute the value of this into this equation. So that will be so we don't know the value of p, and k will be 0. So when you substitute that, we will be left with y. So in that question, they state that it is 160 meters above the road. So that will be over here. So now we can substitute that value into this equation, which will be x is equals to 0, as you can see, and y will be 160. So now we can find the value of p. And divide both sides with 640. So now we're going to substitute that value in again inside the equation, which will be So 4 times 640 will be 2560y. And now we're going to substitute 200 into the x value. So now we're going to find the value of 200 minus 640 square, which will be negative 440. So we're going to divide the value to find the y. So it will be, but we are going to round off the value. So to round off, we will get 65 meters.
Okay, so this is one of the problem of parabola lah. At the water fountain, water attains a maximum height of 4 meters at horizontal distance of 0.5 from its origin. If the patch of water is a parabola, find the height of water at the horizontal distance of 0.75 meter from the point of origin. Okay, so in this question, the water is a parabola. Okay, so firstly, we need to sketch out the graph first law. After we sketch the graph out, we need to write down all the data given. So from the question, we know that the vertex is 0.5 and 4, and origin is a point on the parabola. And we want to find the unknown y when x equal to 0.75. So we write down the equation first law. X minus h squared equal to negative 4p times y minus k. We will need to find, in order to find the unknown y, we need to find the value of p first. So we have already know the vertex is 0.5 and 4, and we sub law h equal to 0.5 and k equal to 4. And the x and y, we can sub any point on the parabola. Okay, so we know that the origin is on the parabola, so we sub the origin as x and y law. Then we get 0 minus 0.5 square equal to negative 4p times 0 minus 4. And we can get 0.25 equal to 16p. Then p equal to 1 over 64. After we get the value of p, we can find out the unknown y law when x equal to 0.75. So the vertex is the same lah, which is 0.5 and 4, and we sub as h and k. And now the x is different, which is 0.75, and the y we remain y law, since it's unknown ma. Okay. So we sub inside, we get 0.75 minus 0.5 square equal to negative 4 times 1 over 64 times y negative 4. Then we get 0.25 square equal to negative 1 over 16 times y minus 4. Okay. Then 1 equal to negative y plus 4. And finally, we can get the value of y law, which is y equal to 3. Okay. So when x is 0.75, y is 3 law. Easy busy, right?
Parabola is one of the conic sections that we often see in our daily life. We use it to make bridges, roller coasters, and satellites, like explained earlier. The general equation for parabola is stated in the slide that is shown, where p is the focal distance, hk is the coordinate for the vertex. So that's it for me.